This is very important problem. Okay, if R0 is equal to 0, R1 is equal to 1, R2 is equal to 2, R3 is equal to 3. Okay, explain or find the content of register R0, R1, R2, R3 after the following instructions are executed in isolation. Mention if the current program status register is updated or not. So in the exam they may ask you explain these three instructions: mul R0, R1, R2, MLA R0, R1, R2, R3, mul R0, R1, R2, R3. Then you can take this simple instructions example: R0 is equal to 0, R1 is equal to 1, R2 is equal to 2, R3 is equal to 3. For all instructions you can take this simple only. In R0 take 0, R1 you take 1, R2 you take 2, R3 3. Then explain so that easily you can explain. So first instruction is mul R0, R1, R2. So this one is destination is, this is multiplication, destination is R0, operands are R1 and R2. So 32-bit content R1, R2. So this is a small number 16-bit multiplication because only one destination is given. R0 is the destination, R1 and R2 are going to get multiplied. So R0 is equal to R1 and R2. So in R0, in R1 we have 1. In R1 we have 1. In R2 we have 2. So 2 into 1 is 2 only. So that is the answer. In R0 we have 0x00002. That is multiplication of 2 and 1 is 2 only. And it is actually multiplication of this 8-bit and this 8-bit. This 8-bit with this 8-bit. 2 and 1 is 2 only. And it is 16-bit. 16-bit 2 is this one. Okay. This is upper result per 8-bit and lower this is multiplication of 16-bit and 16-bit results in 32-bit. So this is lower 32-bit, lower 16-bit. This is upper 16-bit. Multiplication of two 16-bit results in 32-bit because size of this bits is this. Second instruction, MLA, multiply and accumulate. So this instruction is going to this is destination. Multiply and accumulate means we have to add, multiply and add. So multiply which two? R1 and R2. Multiply R1 and R2 plus add, accumulate means plus add this R3. So multiply R1 and R2. 2 into 1 is 2 only. For that result add extra this 3 R3 register. R3 register is 3. So 1 into 2 is 2. 2 plus 3 is 5. So this is multiply and accumulate. Multiply and accumulate. So answer is 5. So after the instructions R0 is 5. Okay, R1 is original value of R1, R2 is also original, and R3 is also original. Only thing is this is R0 is multiplied and after accumulation added with this R3 content, updated with R0 is updated with 0x0005. This is the answer. And here mention the CPSR register is updated or not. Since it's arithmetic instructions, okay, if it results in 0, definitely CPSR is going to get update. Okay, CPSR is going to get update in all the arithmetic instructions, but there is no S term is there here. There is no S term is there. You can write here. Anyway, 0 flag is not there. No, this is R0 is not equal to 0. This R0 is also not equal to 0. So here you can write for these three instructions, you can write these two instructions, you can write CPSR is not updated. And you can also write there is no suffix S. Okay, so that's why flags are not going to happen. Next it is mul. Mul for both this CPSR is not updated. Now this is unsigned multiplication long. Unsigned multiplication long. So since it is long, 32-bit, two destination registers are required. So R0 and R1 are the destination registers, and source are R2 and R3. So you have to multiply R2 and R3. Then lower bit will be stored in R0, upper bit will be stored in R1. So let me multiply these two. So if you multiply, if I multiply R2 and R3, in R2, I think I told no, in R2, 2. In R2, 2 is there. In R3, 3 is there. Okay, if you multiply 3 and 2, if I multiply this 3 and R3 is 3, R2 is 2, 3 into 2 is 6. So 6 will come. Okay, this is 32-bit and 32-bit multiplication. Okay, R2 is 32-bit, this is 32-bit, 32-bit and 32-bit is 64 bits. It results in 64 bits total. Out of that, okay, in R0 we have 6. In R1, this is, I think, this is upper beta. This is upper byte, this is lower byte. I think you have to check. I think this is lower byte or this is upper byte. You have to check. Okay. Lower 32-bit is in R1, lower 32-bit in R0, upper 32-bit in R1. I think this I will confirm. We'll check these two. Okay, but the source resistance R2 and R3 are same. Let me check in R1. R0 is on R1. Let me check that in the instruction set. I have doubt here. Multiplication, go to multiplication instructions. Then you have to check in which register we are doing unsigned. No, we are doing unsigned multiplication. SCO. Oh yeah, this one we are doing unsigned multiplication long. So first one is higher. This is lower. Higher, lower. Okay. Higher, lower. If I multiply to, that's why you have to refer the textbook also. Sometimes if I multiply these two, this is R0 is 2 into 2 is 4. No, 2 into 2 is 4. So in R0, lower will be there. In R1, higher will be there. Okay, correct. This is lower, this is higher. Unsigned multiplication. They have taken these two examples. So you can take any numbers and you can explain with examples. So this is R0 is lower, this is higher. So I think it is correct only. This is lower, this is higher. Higher bit is 000, because if you multiply 0002 with 0003, answer is 64 bit. Out of 64 bit, upper 32 bits are 0, lower 32 bit is this. So this is correct.